Did you just say you were a mermaid? And you said you would sink?
I sink. Oh, I can swim. It's just I sink. If I try to sit there and float, I just sink.
Okay, well, synchronized swimming, you're swimming, not sinking.
Yeah, but actually, it's a debate.
You have to rest.
No, synchronized is not sinking.
Eli can't swim.
There's also swimming. That's another.
Yeah, I swim in the
What, Maddie?
No, my legs.
Okay.
Pretty dense.
They don't have legs. Who doesn't have legs?
Then how would they move their tails? Yeah, how would they move their tails though?
You don't have hamstrings.
You don't have hamstrings.
Okay, but in the movie, when they go on land, they have legs.
Yeah, because they change
Where do their
into
legs go when they grow their tail?
Or they don't have
When they just emerge and disappear. Is that what you're telling me? Yes. They
Yes.
just a muscle.
What movie
are you
Bro.
What's the?
Parts of the
it's a TV
Caribbean is-
show.
Yeah. Parts of the Caribbean, they have the mermaid in the glass tank and then she falls out.
Yeah. What's the mermaid TV show? What am I thinking of? Yes. When they go on land, they have.
Talk about bubble gum.
No,
It's
we are.
When they go on land, they have.
We
legs.
are.
When they get wet, their tails grow back.
Imagine.
And then they flop their tails, you can like see the.
Those aren't
They still have their
And
legs.
they'll have the legs.
No, they're not.
Tail.
They're different creatures.
It's just
Thanks,
encased
thanks
in the
for
It's like a cocoon. Facts.
wasting
See?
my
Yes.
time with.
So they have to
Yeah,
have
I feel
hamstrings then.
significantly stupider
I guess
than I
in Harry
did
Potter.
2 minutes ago.
So
in
they're
Harry Potter, when they like are swimming, you can see their knees.
yeah.
So
So
I
they
guess they
have
do
to
have
have
legs.
hamstrings.
I guess
Yes.
they do have legs.
They'd have to have some strong leg muscles. as well.
Okay, anyway.
Facts.
Anyway.
And they would have to
And
have
their
joints
joints.
in their tail in order for them
For
to
them to
swim.
bend it like that.
Yeah.
Like a fish.
I'm not
Because fish
stupid.
go side
You
to
guys
side.
are
They
stupid.
don't go like a dolphin. Dolphins in that one dolphin.
I wonder if Levi was weighing in on this. 2 hands up, I'm weighing in on the mermaids. Okay, we are talking about solving trigonometric equations today. So, we're gonna start with the super easy equations. Okay, these are called basic equations. Go figure. The reason that we're emphasizing the easy ones, okay, the reason that I'm emphasizing the easy ones to you is because our strategy for the ones that are more difficult is always to get it back to a basic equation. Okay, so if you know how to solve a basic one, then we're just applying other algebraic principles to solve this, okay? So when we talked about solving a trig equation, we're looking for something that might be like this. So sine x is equal to square root of 2 over 2. Okay, these are all going to be exact values. We're not going to talk about non-exact values until later. So if it's exact values, then you know it has to come off the chart, off the circle. Okay, so I want you to listen very carefully. This is really important. This is going to like make or break points, a lot of points on your tests and quizzes. Okay, so what undoes? We have to get x by itself. Anytime that we're solving an equation, we have to get the x by itself. That's how you solve an equation. What gets rid of sine? Sine inverse. Correct. Which is why we talked about inverses in the last chapter. So if I want to get rid of sine, I sine inverse the left side and I sine inverse the right side. So then I'm left with x is equal to sine inverse of the square root of 2 over 2. Now, this we did in the last chapter. That's square root of 2, sorry. Square root of 2. We did this in the last chapter. It's quadrant 1. And the answer is pi over 4. Now, here's where this gets a little bit bizarre. Okay? I want you to think about the graph of sine. So let me just make you a graph of sine a second. Here's sine. What's the domain of sine? The domain.
All
All real numbers. So sine goes infinitely to the right and it goes infinitely to the left. So if this is the square root of 2 over 2, which is like 0.707 something, oops, should be straight, but you know, how many answers are there? There are a lot.
Infinitely many.
There are infinitely many. We don't want to write them. We don't write infinitely many, but here would be like, this would be pi over 2 here on the graph. So this is pi over 4. So we got two problems. We've got the problem that I would say that this and this and this and this guy, those are related. Those are the pi over 2, square root of 2 over 2's on the upside of sine, right? When we're coming up, that's where we hit square root of 2 over 2. How far apart are these guys? 2 pi's. Why 2 pi's? Because that's a period. They're one period apart. And so what we do to indicate that there are infinitely many solutions that are 2 pi apart is that we do this. We put pi over 4, that's where that is, and we put plus 2 pi k. So that k, you can just plug any number in. So you don't have to do that. You're not doing it, you're writing it. But watch. If I put a 1 in for k, then it would be pi over 4 plus 2 pi. That would give me this one. If I put a 2 in for k, it would be pi over 4 plus 4 pi, which would give me this one. If I put a 3 in for k, it would give me pi over 4 plus this one, which would be 6 pi. It's just a way to get any answer. You don't have to find them. You just report your answer like that. Okay? That's the first issue. The second issue is that we have this guy. Like, how do we get that? Your calculator will only give you one answer for sine inverse. So if you were using sine inverse on your calculator doing this, it would only give you pi over 4, which is 0.785. So what you have to do to get the second answer for sine, okay, this is a little bit weird, but it's so important, okay? So to get this, we'll call it the other answer, you're going to do pi minus the first answer. Okay, so pi minus the first answer. So you're going to do, right here, our first answer is pi over 4. You're going to do pi minus pi over 4. Okay, got a little fraction math going on. 3/4 pi, right? Because this is one pi, right? So that's 4 over 4. So that's 3 pi over 4, but also plus the 2 pi k, because all of those downsides of sine right here when we're going down, those are all also a period apart. Now, the good news is sine is the most complicated of them, right? And it's not complicated. You just have to do pi minus the first answer. The other ones are easier. Okay, so let me have you try sine x is equal to -1/2. Okay, let's talk this one together, and then I'll have you do one more by yourself. Okay, so sine inverse. You're gonna feel like this. You're gonna feel like it's stupid to put sine inverse, but it gets harder. Okay, so write it because it will get harder, and then you got to know what you're doing. So x is equal to sine inverse of -1/2, which is what? Yep, negative pi over 6. Pi over 6. Negative pi over 6 plus 2 pi k. Because you have to report all of the answers. That's the quote unquote, this is the all of the answers part. Okay, now we have to do pi minus the first answer. So pi minus pi over 6 is what? 7 pi over 6 plus 2 pi k. And you're done. That's it.
Right. Can you explain that again?
Which part? You want the whole thing? So remember that sine is the y value. So here's the sine of negative 1/2 is at negative pi over 6. Okay, so that's where we got the first one, plus 2 pi k. Sine is pi minus the first answer. So pi minus a negative is a positive. So 6 over 6. Because that's 1. Subtract the first answer. Pi minus the first answer. You guys, the other important thing is it has to be in that order. Okay, it has to be pi first. Pi minus the first answer. Otherwise, you won't get the right answer there. Okay, this is super important. Okay, now you guys try. Let's go. Sine x is equal to square root of 3 over 2. It's a good day to be here, by the way. This is not a day that you would, I don't know, I just feel like, you got, this is so important for the rest of the things in this section. Okay? So you get x equals what? Pi over 3 plus 2 pi k and? Okay. Okay.
2 pi over.
Okay, so Andy, square root, or excuse me, inverses. Inverses is, you gotta go, you have the answer, right? I know what the sine is. You have to figure out what angle. So sine is the y value. So you're looking for what y value is square root of 3 over 2. It's right here. Right here. Which is pi over 3. Because that's the y value of square root of 3 over 2. It's warming up outside. What is the other one?
2, wait, x equals 2 pi over 3 plus 2 pi.
2 pi k. What?
You know Cheech and Chong?
I know what that is. It's the old time radio show.
Yeah.
Okay. Questions on this?
Once you find the inverse, you
Andy. Sine, always. Find the answer. Okay, find that angle plus 2 pi k. Done. Okay, just tack it right on there. Tack it on there. Then pi minus the first answer. Pi minus the first answer. So 1 pi minus a third of a pi is 2/3 of a pi. Plus 2 pi k. Tack the 2 pi k on the answer. Okay, you guys try this one for me. No, you did that one for me. Okay. Okay, so let's talk cosine. Okay, so cosine. How do you get rid of cosine? Cosine inverse. Okay, so x equals cosine inverse of 1/2. Okay, this is the circle part. Just get the first answer for me because you don't know the trick for cosine because the trick is different for cosine. Okay, what is it? Pi over 3. Now, let me ask you this question. What's the period? How often is that going to repeat? 2 pi. That's still 2 pi k. Okay, that's not the trick part. So here's the important one. To find the second answer for cosine, it's just the opposite of the first one.
Oh, so it's just pi, 3 over pi.
Mm-mm.
No, it's the first answer minus pi.
No,
No, it's
Oh,
just
it's
pi.
just-
It's negative. It's negative.
Oh, it's just.
Oh.
Okay.
that's what opposite means, my people. Okay, so cosine is easy, right? You just once you get one, you just make it negative.
Okay, but you said the first one is the first one.
Yeah, that didn't make sense.
Yeah, that's what I thought.
I didn't know you meant
Oh.
the first one. I thought you meant
Okay.
the first.
I got what you're saying. It's opposite of the first answer. Then that's what we need to say.
Oh,
Okay, so no tricks on that one. Like that's pretty much it. So let me have you do cosine x is equal to negative square root of 2 over 2. So all of the studying that we did, all of the stuff that we did last chapter on the inverses and using the circle to find inverses still applies because we use this when we solve. Mm-hmm.
where's my negative two?
Plus 2 pi k. Always. And then the other one is just the opposite of the first one. So, if we have negative 3 pi over 4, you also will have. I'm sorry, I just told you that. If you have 3 pi over 4, you will also have a negative 3 pi over 4.
So,
Lower your two cubes.
Are you really okay?
I think we can just move on to the reset room.
And then you do pi minus the first one. You didn't write any of the second one stuff.
You can go to the reset room.
Like this one.
Yeah, you really.
I can go through
3 pi k and then
I've done this.
plus 2 pi.
They're like perfectly curled. Like, you know, I have to like really high.
Simon, you see what's going on?
Right, so this one would be
Self-described.
minus
Why do you guys
I
try
get
that?
a lash lift because why do we?
minus the negative.
I've never.
Every
No,
day.
I realize
Oh, wow, let's just
Oh,
try
that's
that.
great. That's way more. I've never like.
I can't answer anything.
Okay,
But
Okay.
every day I don't put my eyelashes and put on mascara, and Javon's like, "Oh, you look tired today."
who said that?
You
What?
Oh, well, that's his. Mainly always up there.
Okay, what do you get? What are your two answers?
X equals pi or 3 pi over 4 plus 2 pi k.
Well, that's Javon.
Javon, stop talking, please.
Bro, are we serious?
I heard you. I just want you to be quiet. If you be quiet, then I can hear the other people talking and I can yell at them too.
Yeah, you're right. I'm not even that.
You're being
That's
very-
not how that works.
Negative pi over.
Last time I said sounds not cancel.
Plus 2 pi k.
Trevor, you want to be quiet too? Javon, would you like me to explain the concept of triage to you?
Yes.
Do you know what that is?
What is that?
When you go to the emergency room,
Oh, that gets you.
you go to the emergency room, what do? They take the people who are worse, right? They take like if there's a bunch of people in the emergency room and you have somebody that has cut their hand and you have somebody who is having chest pain, they take the chest pain person first because they're more likely to die, correct? Okay, so then they go, oh, we take the worst and then we can treat the rest, right? So listen to me. I ask you to shut up because if you are not talking, then I can hear the other people who are talking and then I will yell at them. I know this. That's why I ask him to be quiet. Oh my gosh. Oh yes, I am. Okay, why don't you try cosine x equals 0, please.
put I told her
Yep.
it's 0 to
Pi over 2.
Okay, so I heard somebody say, doesn't cosine have to be on the top half? Correct. So you're doing cosine inverse of 0, which has to be on the top half. What is it?
Pi over 2.
Pi over 2. So pi over 2 plus 2 pi k and
Negative pi over 2 plus 2 pi. Thank you.
okay. Cosine, easy. Here's the good news. Tangent is easier. Tangent is easier. Yep.
Wow.
Dang, this is the first lesson where it started out hard and got easier. It's impressive.
I was worried at the beginning because I was like, that one right half the page.
No, that's because it's notes. That was the notes part of it.
Yeah, and then now it's just like 2 lines.
Pi over 4. Yeah.
So observant.
Too busy talking.
I wasn't even talking.
You guys, I really would like you to focus. Okay. So tangent inverse of both of these guys. So x is equal to tangent inverse of 1.
Wait, was tangent top half?
Nope, tangent's right half.
Oh, I did it wrong.
Pi over 4.
So x is pi over 4. Now, let me ask you this question. We talked about this. We don't talk about tangent a lot. We're not used to him. But how often does he, let me give you a graph. Okay.
Yeah.
So let's go like this. Tangent's an ugly graph.
It's like the
I think it looks like this. I think that's tangent.
pretty close.
I mean, I think he goes, well, I think he's the one that goes through 0. So if this is 1, okay, this would be our pi over 4.
It does go to 0.
Thank you.
She's got a lot of information up there.
A lot of
Gotta sort it out.
Connor.
She's got to figure out how to
Hey, so here's my question. How far apart are these repeaters?
Pi.
1 pi.
How am I supposed to know that? Is it half a period?
What's the
No,
period of, on your
period for
papers,
sine.
on your papers, you have the period for sine.
I don't remember which.
It's just a long time ago that we talked about it.
It's on page 5.
It's on page 5. So, tangent repeats itself every time. Now, that's the first thing. Sine and cosine, because they go up or down, there's 2 answers. How many answers are there? That's why tangent's the easiest, because there's only 1 answer. You don't have to find the second answer. So, plus pi k. So pi over 4 plus pi k. Okay, so let's do, let me have you do tangent of x equals negative square root of 3 over 2. The worst part about tangent is figuring out the tangent.
I agree, that's why I don't like it.
It's not going down.
It's 5 pi over 3.
I'm gonna take your word for it.
It's not 5 pi over 3.
Just kidding, stop lying to me.
How about
Is it
5 pi over 3 is not in the area that you, are you on the right half of the graph?
Yeah.
Then you can't call it, you can't call it 5 pi over 3.
pi over 3?
I don't know, actually, off the top of my head. Okay, so listen,
I don't know.
you guys,
And yeah,
here's how I remember. If the squared, it's y's on the top, right, for tangent? Y's on the top. This guy's going to have the square root on the top. That's where he wants to end up. So it's actually pi over 6, negative pi over 6. I'll show you. So it's y over x, right? So keep, switch, flip. One of these is positive, sorry. So keep, switch, flip. Square root of 3 is on the bottom. Oh, this should be a 3. That's my fault. Okay. Square root of 3, square root of 3. So square root of 3 over 3. That's pi over 6.
Why'd you change it?
Because I made a mistake. So,
shut up.
negative pi over 6, just a second. Negative pi over 6 what?
Plus pi k.
Plus pi k. Carson.
What's the difference on the circle? Bottom ones and then the ones who are in the middle with the negative pi.
So when we use the negative, when we're doing anything with an inverse, okay, so Carson's question is a good one. Why are we not using these guys? Why are we using these guys? When we do anything with an inverse, we use the negatives. Okay, so sine inverse and tangent inverse will have those negative angles. Okay. Now, let's talk about, I'm going to talk about one of these because it should be quick. So let's say I asked you to find 2 cosine x plus 1. I asked you to solve that. Okay? Now, so listen, here's what I want to tell you. Your goal is to take whatever I give you in the realm of solving and make him a basic equation because you know how to solve a basic equation. He's not a basic equation because he has a coefficient on the cosine and he doesn't equal anything other than 0. Okay, so you can do this. This is not hard. What are you going to do?
Subtract 1 and then divide by 2.
Minus 1 and divide by 2. So I'm going to do that in one step. So this would be cosine x equals negative 1/2, which I think we already solved. No, we did not. So go ahead and solve that. We did positive 1/2. Cosine is the x value.
Is it 2 pi
Okay, so what's the first answer that you get off your circle?
2 pi over 3 plus 2 pi k.
Okay, that's the one that's on the circle. Cosine is your x value. This is the cosine. Remember, cosine is top half. This is the cosine that's negative. It's 2 pi over 3. So x, the other one is?
Negative 2 pi over 3 plus 2 pi k.
There you go. Okay, so you will see some like this on your homework. Don't freak out. Just make them look like normal, just like you would solve a regular equation. Now, I'm going to tell you this. Let's do this. So let's say I have secant x is equal to 2. Okay, so this is annoying because secant inverse, I don't really want to use secant inverse, and here's why. I could use secant inverse and I could do a bunch of voodoo with the circle and call it good. We're going to make our lives a little bit easier. Okay, also, when we start doing things that are not on the circle, this way I'm going to show you is the only way to do it. So what we're going to do is make it so you only have to learn one way. Okay, so what you do when you have secant, cosecant, or cotangent. Okay, so any of the minor 3, not the big 3, but the others, is you turn them into sines over cosines. This is sine over cosine, right? So this is the same as me solving 1 over cosine is equal to 2. I'm going to make 2 a fraction. Okay, listen. Secant, no, actually it's easier than that. Secant is 1 over cosine, right? Do you agree with me? And 2 is 2 over 1.
Oh, yes.
Okay, that's all I did.
Okay, that makes sense.
Now, here's the trick to this. You can flip, as long as you do the same thing to both sides, you can do whatever you want. We're going to flip both of them. So this becomes,
Equals cosine equals 1/2.
it's going to be cosine x equals 1/2, which is significantly easier to do on your circle because you're not dealing with any of the reciprocals. This is the x value. Okay, and we already solved this, so we're not going to solve it again. Okay, so let me have you try cosecant x is equal to 2 square root of 3 over 3. Now I'll do a little bit of work on this one, but not a lot. It's already a fraction on the right-hand side, so that makes your life a little bit easier. Yeah. If you want to be able to find it. You guys are making me nervous. I thought I did it wrong. Let's talk through this one, okay? Cosecant turns into what?
1 over sine.
Okay. So it's 1 over sine equals 2 square root of 3 over 3. Flip them both. So we have sine x equals 3 over 2 square root of 3. Now, if we're going to rationalize this, the only thing that you have to deal with is the square root. So square root of 3, square root of 3. You can take the 2, just make yourself a mess. So you take the smallest thing possible. So the top is 3 square root of 3. The bottom is 2 times 3, right? What happens with the 3's? So sine x is equal to the square root of 3 over 2. Now it's on there. I know. Okay, so what do we have?
X equals pi over 3 plus 2 pi k.
Okay, pi over 3 plus 2 pi k. Now the good news is you don't have to think about cosecant. You're solving a sine equation. You know how to find the other answer for sine. What do? Pi minus pi over 3, which is what?
2 pi over 3 plus 2.
Okay, so don't even worry about cosecant, secant, or cotangent. You just flip them. You just flip it. Okay, so your homework. Oh, don't even. Is page 375. 23 through 30.
I've never heard that said.
That's not saying no one said.
Yeah, but I say it's the same.
No, it has to be more than one person.
Wait, what did you just say?
No, something about gold star.
You don't even know what it is now.
Yeah, but it's his saying, so it doesn't matter if you know.
That would be like his catchphrase, not his saying. Not a saying.
Isn't a saying a catchphrase?
No,
Or are they the same?
a saying is actually more than one person said.
I mean,
Yeah, a catchphrase is just like one
Yeah,
person
that's why I
saying.
It'd be like-
behind it.
Wait, now. Wait, what is
There you go.
it's philosophy.
I know
Yeah.
which one.
That's it.
Maybe it has one.
They're like making like tea and
Sweets.
That's like
That's
the.
the stupidest idea ever.
I
No, it's every time.
No.
Scooby-Doo is one of the best TV shows ever created.
No, that's so dumb. Like if
No,
you're
I love
trying to catch a killer.